I'm June. I'm going to start first. First, good morning, afternoon, whatever. Welcome to our Math+C session. We're sharing today about a set of microworlds that we are developing in SNAP. The microworlds are focused on integrating programming into elementary mathematics, and we're excited to share these kind of prototypes we've been working on for a little while with you today, and we welcome your reactions. Next slide. We'd love to know a little bit more about you and your interests, why you came here. Please put your name, your institution, what brings you to the session today in the chat, if you could. And for anyone who would like to learn more and get updates on our work on an ongoing basis, you can do that through the Google form link that will be available. Next slide. As I said, I'm June Mark. I'm from Education Development Center, and we're a nonprofit research and development organization in the US. We've been working with SNAP for many years, and part of our team worked on the Beauty and Joy of Computing curriculum with our UC Berkeley colleagues and SNAP developers. And our team is a sort of collaboration amongst a number of expertise and experiences, including mathematicians and computer scientists, curriculum developers, education researchers, elementary teachers and coaches, and SNAP developers. With me here today are Paul Goldenberg, Deborah Spencer, Kristen Reed, Kate Coleman, Katie Chipinelli, Zach Kolar, Bernat Romagosa. You won't hear from every single one of us, but we're all here today. You'll hear from many of us. Next slide. We are really fortunate to have wonderful partners at an elementary school that's close to EDC. It's the Waltham Public Schools, and we are working particularly this past year in the Plympton Elementary School. And the district serves a high percentage of students who are English language learners and maybe from low-income families. And we've worked there closely with the math coach, the digital literacy teacher, the principal, and the second, third, and fourth grade teachers. It's been a tremendous collaboration. And we're also really lucky that the school's digital learning teacher, Zach Kolar, is part of our EDC team as well and supports our Microworld development. And Zach's actually going to provide you with an overview of the Microworlds next.
All right. So the Microworlds are a series of mini units that incorporate, that fit into the math curriculum for elementary students and teach them math through coding. So each Microworld takes the place of 2 or 3 days of math instruction, and it's targeted towards a specific set of mathematical standards. So one of the Microworlds that we've done is a number line. So as you can see, this is a very pared down version of SNAP. So students only get access to a few blocks in the beginning to kind of not overwhelm them. This was shown to second graders first. So you can see these blocks are plus and minus 3. And then there's this dinosaur right here that's giving them a series of puzzles to try to solve. So this puzzle says, try to label all the numbers from 0 to 10, just using some combination of these 4 blocks. So they're moving around on the number line. The Microworld can be extended. So we have a fraction version. So same mechanics, but now instead of whole numbers, students are working with plus or minus 3/8. So it kind of supports their development as they get farther into the math, using the same underlying mechanics. We've got a place values Microworld. So now we're moving away from the number line and students are focusing more on the relationships between ones, tens, and hundreds, doing a little bit more in their heads, and getting into thinking about the relationships between slightly bigger numbers than they were on the number line. We have a town map. So this gets into the coordinate system. It's, as you can see, introducing some more programming things as well. We've got repeats. We're thinking about the distances between different destinations and stuff like that. We have an arrays Microworld. This is getting into pre-multiplication or beginning multiplication. Students are now trying to use the blocks to recreate various designs that have certain numbers of rectangles that are different colors. They're thinking about the total number of squares that make up each rectangle given the number of rows and columns. And then on the programming side, now the order is starting to matter a little bit more, like the order they put the blocks in. Whereas in the previous worlds, the order, as long as you had the right blocks, the order kind of always gets you to the same place. But now you need to think about what goes inside the repeat. Do I need to put the pen down first or change the color and things like that? And then the last kind of microworld that we have is this multiplication world, which gets a little bit more into functional programming. So instead of building scripts or programs that are tall, now we're building out wide options, getting a little more into inputs and outputs instead of just commands, and a little tiny bit of lists. They're not doing a whole lot with lists yet, but they're at least introduced to the idea that there's something that exists that can be used to keep track of various things. So that was obviously a very quick overview. We'll give you a chance to explore these more in depth later, but we just wanted you to be able to kind of visualize what we're talking about until we get to that point. So if you have questions or if you want to try this out, don't worry, that is coming.
Well, thanks, Zach. So I'm going to just talk a little bit about our hypothesis, our project, kind of give some context around it. So you can see here, we have our hypothesis, but what I'd really like to highlight on this slide is that we are programming for the sake of the mathematics. So this isn't a standard language. This isn't a mathematics language. This is a programming language. And I think one of the things that's really important to mention here is that because it's a programming language, it's a process language. So for students, they're getting immediate feedback on their work, whatever they make, whatever script they're building, they can test out, and then they can refine it. And I think that's very different than sort of the traditional mathematics environment where it might be a paper pencil tasks where students might do something, might solve a problem, whatnot, and hand in that work, and they might not get that feedback, back for either that during that math lesson or even for another day or so. So, in doing so, we really want programming to be an opportunity for students to be able to learn mathematics and enjoy mathematics. Next slide, please. So these are our design principles. I'm not going to go into depth at the moment on any one of them, but they're here for you just to take a quick read and learn about. What we are planning on doing is, as the session continues, Paul is going to do a demonstration of a microworld. We're going to give you a chance to go into any of our microworlds to explore. And so what we want to do is at least have you be aware of our design principles. But I think our feeling is once you have a chance to experience the microworlds yourselves and we go into they will make more sense when we go into greater detail on these design principles later in the presentation. Next slide, please. Thank you. So one of the things that we really wanted to call attention to is building in opportunities for equity. And so one of our principles is that really we are making sure, and Zach already mentioned this, that these microworlds are integrated into sort of what we would call like the tier one, the main math instruction that's happening in a classroom. It's not a separate thing. It's not a pullout. It's not an additional extracurricular, that students are learning the mathematics and doing programming during the mathematics time in their classroom, and therefore it's reaching all students. Secondly, in terms of our problem sets, we want to have entry points. So our tasks are built with are designed to have low threshold and high ceiling in terms of their design and our problems, so that no matter where students are coming from, students are able to enter and access the puzzles. Thirdly, we are really in tune with supporting access and language development for all of our learners, but in particular, and June talked a little bit about this when she talked about our teacher partners, but the Waltham Public Schools, our partner district, has a very high number of English language learners. We also have developing readers. So we're doing things, and you'll see this later on, where we're building in audio, so that if you're a developing reader and you need some support to read the puzzle text, you can just have Dino or read the puzzle to you. We're also being very thoughtful on what language we're using as we're designing the puzzles themselves, as well as building in translations so that students can access these environments, not just in English, but in Spanish, and we're moving into other languages as well. And lastly, we really want children to see themselves with positive sort of computer science and mathematical identities, that they view themselves as being able to do this work in both mathematics and CS.
All right. So while the main focus of this is the math, they also pick up lots of different programming skills along the way. So one of the things that kind of surprised me at the beginning with the second graders is that even building scripts, like the idea of putting the blocks together, is much more of a skill than I expected. When the kids are first introduced, it's very tempting to treat the blocks more like buttons and just say like, oh, like hit the +3, and then you go +3. So it's more of a jump to get them to think of it as like, all right, now I need to list out all my steps, connect them together so that I can see what I did or recreate this. So even seemingly simple things like that are something that that this really helps teach, and then kind of lays the groundwork for these other concepts that are, I think, a little more self-explanatory.
Can I interrupt for a second, Zach? One of the things that we say to the kids is connect this with language, and that's partly for the sake of the teacher as well. They get all these little blocks, those are words, and they're putting together sentences. And when they can put together a sentence that articulates something they want, it lives, unlike the sentence in mathematics that they write on paper, which could be right or could be wrong, but they have no idea. It just sits there. Go ahead.
Wonderful. So we just wanted to show you in this slide the variations on the different worlds. And you kind of have already had a preview when Zach showed you the GIFs. But we have obviously a number of different environments here. And if you click onto the next slide, Zach, this just shows the variations in the number line environment. So, and there's many more ways we can take this, you know, we're aware of that, but in our environments now, we started with sort of the more basic number line environment, which is starting with single digit whole number integers. We've moved into doing that with larger whole numbers, like in the hundreds, as well as fractions in our eighths environment, and then in our halves environment. Something also to mention is that we're in the process of developing a decimal number world, also rooted on the number line. So yet another variation to this world.
Now, if you can turn it over to, or unshare so that I can share. Yeah, thank you. Let's see if I can grab the right thing to share. It is here. There. Earlier, Kate mentioned that I'd be showing how to use this multiplication microworld. This is actually the first of several. There's one, right? This one only presents one operator. And well, little Dino is now saying, drag out an orange block and click on it, see what it does. Well, it speaks, it doesn't do very much of anything. But I can multiply it by something. Same thing. Or that. Oh, that's new. Or I can, now that I have a 10, I can multiply it by 3. And I can put this on my list. And I can put other things on my list. I mean, I can experiment with some of these other numbers. Of course, in each one of these, I get suggestions for things to do. And I get some tools up here that allow me to show my list in a different way. Right now I've made 30, but I want to go back to my list for a moment and put something else in the list. I can get 1 in my list. And we have multiple sets of puzzles. These are the introductory explorations. There are puzzles that give a specific task, like make at least 5 numbers with 3 as a factor, or challenges, what numbers less than 100 can you make? And some of the challenges are quite specific. Make 2 numbers that are greater than 30 and less than 40. And it's been really fun watching some of the kids figure out what they can do, given that these are their only resources. They don't have addition and they don't have any other numbers that they can make, except ones that they can make with these as factors. I should unshare and make it possible to go back. Unless there are questions that I didn't answer. Well, there are millions of questions I didn't answer. Let's ignore that.
Michael does have a question, but if you guys want to hold off on questions for now.
Oh, you're asking about whether we're intentionally showing it as ringed. We are intentionally showing it as code rather than a written out mathematical expression. The ring is just an artifact of what we've been able to do so far. And we have no explanation for that, and the kids probably don't either.
Thanks, Paul. All right, if you're like me, you're probably like wanting to dive right into actually work in these microworlds yourself. So we're going to take some time, about 5 minutes. We're going to put up a timer just so it keeps us on track. And these are active links. So if you haven't pulled up our presentation, you can do that by putting that goedc.org link that's at the bottom right-hand corner into your browser. There's also a handout that I think Kristen put in the chat. But these 5 minutes are really for you to explore whichever microworlds you'd like to. I just want to mention that if you're watching this as a recording, this would be a great time to stop and pause and take as much time as you need to explore and then come back. And if you have any questions during this time, you can feel free to type them into the chat and we will do our best on our team to address them.
The combined steps blocks has fooled me. Don't know what that does.
Sorry, where did you encounter that one, Simon?
That was in 8th, I think.
Yes. Yes. So children actively asked for something like this. We'd made it very early because they asked in the 2nd grade 3 years ago or something like that.
I must be getting too old now then.
No, what they saw was they could make 2 jumps to get somewhere, like go +5 -3 to get to 2, but they wanted to make a 2 block that didn't include the jumps, but just went 2.
With its addition, basically, is
Yes.
it?
So yes, what it does is it
I was thinking sequencing. I wasn't. Yes.
it defers the screen picture until after all the arithmetic is done.
Yes, thank you. Right, I was just sitting there thinking, no, combined steps, no. Right, got it now. Thank you very much.
Pleasure. A general thing is we've learned most of the tricks that we wound up using from the kids. The kids are really good teachers and very demanding.
I'm thinking combined blocks more than combined steps, but that's just me.
Oh, yes, 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 yeah, yeah. Who's in charge? I think we're at the end of
We're almost to the end. We're at the end of our time.
We're stuck at 4 seconds.
We're stuck at 4 seconds, giving everybody a little bit more time to play.
And Brian asked, why no next exploration button?
You mean,
Right.
why just list the buttons and have the kids have to push one?
I think, yeah, or why not have one is how I actually interpret it. But Brian, you can unmute and say more.
Yeah, that was also something that we discussed.
Well,
The-
and yeah, some of the students start in different places, and many of them want to go quickly to the most challenging puzzles. So not everyone wants to necessarily go in order, although that's that whole issue of whether we have the students go in order, especially given that we've spent a bunch of time thinking about the progression of the puzzles, is something we're exploring in our classrooms. But they can just go on to the next puzzle or move forward currently.
It is very weird. We spend so much effort thinking about an ideal progression and then don't make the kids follow it.
Yeah, and some students want to go back, and so wanting to be able to make that possible.
Yeah.
Zach, do you want to, are there any other questions from the playing with the world? And if not, Zach, do you want, thank you. We've talked some about the design principles, and actually a number of your questions that have come up are related to some of our design principles. And so I think you've seen a lot of these in action, but I wanted to highlight just a few of them. This issue of high cognitive demand, low distraction. I think, as you can see, you guys are familiar with SNAP, so you see what we've tried to do is strip away a lot of what these students really don't need right away, and to allow them to be able to focus on the puzzles and the challenges. And we've spent a bunch of time thinking about that progression of puzzles. I mean, that's a work in progress, but really trying to think about the puzzles creating the challenges that students are trying to solve. This notion of experience before formality, some of you may have heard about it in some of our other work, but what that is about is really providing students with their own experiences, playing and exploring in the environment, observing the behavior of the blocks, and thinking about the structure of their scripts and the mathematics underlying that, and allowing students their own ideas, conjectures, their thinking of the mathematics to come through that, and we kind of feel like they're using programming as a sort of active language to be expressing those ideas. And I think in the chat we've already touched on this issue of the locus of control and authority. I think people are really familiar with math apps that tell you you've got it, or you get some bells and whistles. We really tried to avoid that, and really are trying to encourage students to see themselves as the evaluators of whether their methods and solutions work. And we want students to kind of maintain control over their own learning. And the Microworld and their interaction with SNAP, they get feedback. It's in a place where they can experiment and see what happens, and that's really how they judge whether their solutions are working. It encourages testing and debugging, and we really feel very strongly that in mathematics, it's important for students to develop this sense that there isn't an external evaluator. They're creating that. So a number of you have already also asked about editing the puzzles. And so in this next part, Zach and Paul are going to talk a little bit about the tools that were developed here and what we've learned from creating these microworlds in SNAP, and what facilities there might be in the future for other people to develop microworlds and adapt these. So I'm going to turn it over to, is it you, Paul, that's going to start on this?
Yes, I will take this.
Okay, thank you.
So actually, our overall goal, everybody's been saying this, I don't have to repeat, is improving mathematics learning. From the point of view of the NSF that funds us, the object is not the beautiful product, but we have to try to make a beautiful product in order to figure out what it takes to do that. Because what we're trying to do for the NSFSA, these are the difficulties that you encounter, the things that you must do or not do in order to make it work with kids. And the reason that we got into this game with language is that a lot of our thinking about mathematics learning actually comes from thinking about language. Little kids, kindergartners, can write a sentence in English, misspelling most of the words, and you still know what they're saying. But if you get even one character wrong in a mathematical expression, it's wrong. And it's not just wrong, but it's unintelligible, because a change in that character or a change in another character might make the sentence right, but it's a different sentence. So this project hypothesizes using programming as the language for kids learning serves many purposes. It still is precise as the mathematical language that is so punitively concise, but it gives you feedback, unlike a thing on paper. So the kid can be the evaluator and see what happens. So what does it take? What have we learned about the technical requirements so far from the kids? Well, all the tools need to be in one place so the kids' time is spent using them, not looking for them. Anything that they don't need or could cause them or their teacher trouble, like on screen or in menus, has to be hidden. We've had kids edit the stage and suddenly wind up in places that nobody can save them from because the teacher doesn't know it and you can't get around the room fast enough. Make a block is a standard snap button in the palette along with the other nice things. But there are other buttons that might be useful services for kids who have a much more limited world. And there must be also other ways of making a block, like a kid creates a script and you'd like that script to be turned into a block. Many kids will press make a block, name it what they want, and think that they're done without pulling the script in. So another thing that they could do is click on the script and right click on the script and say make a block, and the script is already in. We're desperately eager to handle translations easily. Right now we can. It will become easier because Zach has been doing a lot of work to simplify the design and building of these microworlds, so that anybody who wants to add another translation to the same puzzles can do that trivially. All they need is a list of the translations and they're done. We also would like to be able to make it possible for people to look at a particular puzzle and say, no, I want to change the whole bloody puzzle, and make that really easy. In short, we want to design so that others can easily build and tailor new microworlds, because what we're trying to learn is how to do that. Next slide. So in fact, we're happy to say this is already already happening. City Lab in Catalonia, a couple of people, well, there was a presentation yesterday by Jose Garcia, who was showing some of their website. Actually, let me share right now. I can share my screen again. Share. Oh, I want to move to the, come on, there. There. So City Lab has put up a site. You have a link to it, and they have 3 microworlds. They've built these 2 new microworlds. One of them is this. it's a lovely thing in this world that you don't even have to be very straight. You can do things that you like the way you want them. Here's another one the kids particularly like. Oh, this is a Microworld that we designed, that they redesigned and translated. And one of the things kids particularly like is the task of trying to visit everybody. So they'll make a script, often not as efficiently as, oh, well, let's see, we stopped at Leo. Yeah, we have more work to do. I want to stop my share and go back. But generally, the idea is it's nice for other people to be able to make microworlds and to change ours and to add translations, and that's our goal. Next slide.
Right. So then in this project, I'm kind of wearing two different hats. There's the teacher hat and also the like EDC developing hat. So putting back on my teacher hat, when I was like seeing some of these, we've done 2 years of piloting in my school now. And so I was working with our math coach, who's amazing, and we were trying to figure out if we could just kind of take the existing EDC work in Microworlds and like where else we could go with it. So we wanted to extend to first graders. So we just made kind of a simplified version of the place values Microworld that you may have seen. This only goes into ones and tens. We added the 99 chart so they can kind of visualize where they're going. And we also, I have a Finch robot that the first graders had seen during Hour of Code, and they asked me like every day after that when they were going to use the robot again. So we also incorporated Finch. So this works as a standalone Microworld like the other ones where they started independently working on their devices and they're just moving the little turtle on the screen. But then at the end, we were able to take some of the more challenging problems and as a class, just hit the little toggle robot button and then it starts broadcasting to the Finch on this giant 99s chart. And you can see Paul came to visit us as we were trying this out. And then I also wanted to extend beyond just math. So with the third graders who at this point had seen a year and a half worth of Microworlds when they were in second grade and then the first half of third grade, they were learning about frogs in their ELA class. So I took what was originally a project in the Harvard creative computing curriculum for Scratch and just kind of made a Microworld based on it. So only giving them these blocks so they could kind of write a story about their frogs. And at this point, I think with the unified palette and being able to hide the primitives, you could actually accomplish this now without a Microworld. But at the time, the Microworld was a way to kind of get them more closer to the like real full snap, but again, without completely overwhelming them with like every single possible block when they're still 8 years old. And then one more extension of this, we don't actually know much about this, but we were all very excited to see there's a lightning talk later today by Daniel Jackson that encompasses how to use, amongst other things, how to use the number line even in college math. So we're excited to check this out and wanted to highlight that there are even ways this work is being used that we don't know about yet. So we're excited to see what this is like and where this is going.
One of the first things that a colleague of ours said when he saw the ±3, ±5 Microworld was, oh, linear combinations. Wait, we should be doing linear algebra with that. Go on.
Next is a great opportunity to see a student at work with the Arrays Microworld. This is a second grade student who at the beginning of the year had no programming experience. And this particular puzzle is being completed by her at the end of the 2019-2020 school year. If you have any thoughts or feelings that you want to share after viewing the video or while viewing it, please feel free to share it in the chat. And the task in this puzzle is using repeat, make a script that fills each rectangle on the grid with a different color.
Let's do turn this on real quick. Let me know if you can't hear this. Oh, my goodness.
That's it.
Ah,
And so now we have to do the red one, but instead of 2 squares, 4.
Oh boy,
So now we have to do that one, so we have to go move right. How many spaces? Let's see. Let's move right. 1, 2, 3, 4 spaces. Now after that, we have to move up 1, 2, 3, 4, 5, 6, 7. Now we have to be able to do that all in, let's see, what's it? We haven't done black yet.
no, we haven't done black yet.
Let's just do black. So let's put this all in one area. Let's see how this works. All right.
All right.
That's good.
that is good. It looks beautiful.
So now we just have to put another repeat.
Mm-hmm.
And this repeat is 1, 2, 3. 2 times 2.
Mhm.
So, and then paint a row of 6. This is 1, 2, 3. Yep, a 6.
Mhm.
And after that, we gotta move down 1 row. Now let's see
Yeah.
what this does.
Oh.
All right. Now the rest of it is 6 and 5. Let's see. 6. All right. Let's see. What color should I choose now? I really like the colors.
Aren't the colors fun?
Gold. Okay. Put a repeat. Gold. Gold.
Nobody will be surprised to
Paint
hear
a row of
that not everybody is this systematic.
6.
Mm-hmm.
Wait. And now that I've done that, move down 1 row. What this does. Okay, wait, let's see. Oh, repeat is 5 times. Now let's try.
Look at
Perfect.
that.
Oh, wow.
It filled it exactly.
And one other thing to note on this that I didn't mention initially is that this was actually done in a cognitive interview as opposed to a full class setting.
And just even in thinking about that video, just before we move on to the next slide, I think one of the things that always strikes me, and I've seen this clip a few times already, and this is true, an observation that's been true when we've been in classrooms as well as this year when we've done this work virtually, is just the level of persistence and perseverance that a 7-year-old or an 8-year-old has in solving a problem. I think it's just been so incredible. And Zach, I don't know if you want to unmute and just tell, sort of your reaction very early on last school year when you saw productive struggle.
Yeah, so productive struggle is something, backing up, this, we started the Microworld in my 2nd year of teaching, so I still feel brand new, but like at the time, still felt very brand new. And so I had heard productive struggle used as like something that we were looking for. And I conceptually, I understood it, but I didn't quite get what that actually meant in practice. But with the microworlds, just seeing how kids kind of like they'd raise their hand and think that they need help. But in Paul's words, sometimes they think they need help when they actually just want company. Seeing how you could like kind of stand next to the kid and just as they talk to you about what's giving them trouble, they kind of figure out they answer their own question, or like every once in a while I need to ask like one question, but just seeing how independently they can move through this even when they feel like they're stuck, and kind of building up the urge to, or resisting the urge to like just jump in and like help them right away, versus letting them kind of get there when you can kind of see them working through that mentally on their own.
Great, thanks, Zach. All right, let's head to the next slide. So in terms of just building school support, oftentimes we get questions from people like, well, how did you actually do this? Like, how did you get people, you know, in terms of the school stakeholders involved, teachers, et cetera. And I think these are sort of four main bullets. We've already talked about this very tight alignment with the standards and curriculum, meaning that for a teacher, when we were at, when teachers were doing these microworlds during their math block, they knew that they were teaching mathematics. It wasn't, they didn't feel like they were giving, you know, getting rid or giving up on anything. They very much felt that this was in a very, very tight alignment with what they were just doing anyway in their classroom. We've already talked about the mathematics through programming. There was an incredibly high level of student engagement throughout all of the sessions. I mean, that was just something I think that the teachers, the principal, district administrators who'd come in to visit would see how engaged students were. And I think another comment that we'd often get, or we had gotten from the classroom teachers, was that for students that the classroom teacher may have traditionally not been more disengaged in the classroom, or even struggled a little bit with the content, that particular child in the microworld would shine. So that was really exciting to see and hear from the classroom teacher. And then of course, just this accessibility with audio translation and language support, which we've already talked about, was also a huge way that we built support.
So we've talked about some of this a little bit, but the students' reactions to this were just overwhelmingly positive. It built like lots of engagement and persistence. Sometimes students, if they were getting frustrated with the puzzle, might kind of get sidetracked and say like, all right, I'm on the number line, can I get to 500,000 just by hitting +5 a bunch of times? But even the students who did that would eventually come back to the puzzles. So it was almost integrating like a level of self-regulation by giving them the opportunities to go out of order or explore other things, but almost all of them would come back on their own without needing much interaction or like redirection from teachers. Also, the positivity surrounding this, like the level of excitement that they got over being able to accomplish these puzzles. We had checklists for them to complete as they were working through, and the box for completing the puzzle literally was labeled "I did it," because kids just, as soon as they finish one, they just exclaim, "I did it," because they're just so excited. And it really gives them the control over what they're doing with math, and even thinking about math in a very different way. There was one student who, at the end of the first day of this, the second grader went to the teacher and at the end of the day just said, "We forgot to do math today," because they thought they were just solving these fun puzzles that didn't have anything to do with, or that they didn't realize that they were still learning because it was such a different setup than they were used to. And then for teacher reactions, the teachers also really enjoyed it, partially because of all of the student things. It really made their thinking much more visible. You'll see we have a quote from a teacher who, she had a student who previously didn't, just through pencil and paper, didn't show much of an understanding of subtraction, but then on once she got into the number line, the student just it became clear that the student actually understood addition and subtraction much better than the teacher had previously been able to see. The experience with debugging is a very great way just to introduce that concept, not just for programming, but just in general, we're it's not wrong, we're just not there yet. We need to tweak some things, we need to get to a new endpoint. And it's just a good way if you're looking to introduce programming into your curriculum, this is a way to do it without feeling like you need to squeeze it between existing things, because it integrates so well with the math that you're not giving up time to do programming instead of something else.
So as Paul already mentioned, our work is funded by 2 NSF grants that have allowed us to do this work starting in 2nd grade. And we're working all the way up to 5th grade. And if you're wondering where you can find us, we have a website. So it's on your handout, so you don't need to like scribble and write this down. We do have some Twitter handles through EDC, so you can follow us there, as well as if we click to the next slide. There's our handout. We have all of our contact information. So everything that, we've said, it's on the handout. You don't have to write anything down. All of our contact information, emails, Twitter handles, if we have them, is there. So you can feel free to please reach out to us. And really at this point, we wanted to end, and I think we did, with a little bit of time for questions.